Good morning, students. Before watching this video, please make sure that you have already watched the previous videos in which we have discussed the exercise 4B and the concepts which are necessary for that exercise 4B, equation of tangent, normal at parametric point and Cartesian points, etc. The next one is show that the perpendicular tangents drawn to the ellipse lies on a circle. So this is what we are supposed to prove. That means this is the ellipse. So let us suppose that this is the tangent at this point and this is the tangent at this point, and this is the tangent at this point. So both are perpendicular tangents. So the locus of these perpendicular tangents lies on a circle is what we need to prove. So that means, so if you take this is the tangent and this is the, at this point this is the tangent. So these two tangents are perpendicular to each other. Likewise, so this is the tangent. So this is the tangent at this point. So and at this point this is the tangent. Both are intersecting at both are perpendicular tangents. This tangent as well as this tangent are perpendicular to each other. So all such points if you join, it represents a circle is what we need to prove. So proof. Let us take the equation of the tangent in its slope form. So let the equation of the tangent in its slope form be y is equals to mx plus or minus square root of a square m square plus b square. So I'm talking about this tangent. So at this tangent, at this point, this is the tangent. So and at this point, this is the tangent. So the point of intersection of these two tangents is this. Let X1, Y1 be the point of intersection of these tangents. Since these tangents are passing through this point P X1, Y1. Since these tangents are passing through P X1, Y1, so substitute the point Y1 equals to mx1 plus or minus square root of a square m square plus b square. This implies y1 minus mx1 is equals to plus or minus a square m square plus b square. Squaring on both sides. So this is y1 minus mx1 whole square is equals to plus or minus square root of a square m square plus b square whole square. So this is y1 square plus m square x1 square minus 2m x1 y1 is equals to square root gets eliminated, plus or minus whole square is plus. So a square m square plus b square. So this is equals to, this is m square x1 square, this is a square m square. So take m square in common, x1 square, this plus a square if you transpose onto this side, minus a square, minus 2mx1 y1 plus, this is y1 square, this plus b square if you transpose onto this side, y1 square minus b square equals to 0. So this is clearly a quadratic equation in terms of m square, m constant. So let m1 m2 be the roots. What are m1 and m2? These are the slopes, because we have taken the tangents, two tangents, therefore there is the possibility of two slopes, m1 and m2, and those slopes are the roots of this quadratic equation. So slopes, product of the slopes m1 m2 equals to -1, because this tangent and this tangent are perpendicular to each other according to the question. So what is m1 m2? C by a. C is ax square plus bx plus c equals to 0. So sum of the roots is minus b by a, product of the roots is c by a. So m1 m2 equals to, what is m1 m2? C constant by the m square quotient. So y1 square by b square by x1 square by a square is equals to -1. So this is y1 square minus b square equals to minus x1 square, minus into minus is plus a square. So therefore, this is x1 square plus y1 square is equals to a square plus b square. Therefore, the locus of p, locus of this p x1 y1 is x square plus y square is equals to a square plus b square. So this represents the circle equation. It is seen to be x square plus y square equals to r square. So whose center is at the origin, and radius r equals to square root of a square plus b square. And this circle so obtained is called the director circle. The director circle, so this is the ellipse and the director circle will be like this. So this is the director circle, and this director circle will be formed by how? This, at this point this is the tangent, at this point this is the tangent. So both are intersecting at this point. Likewise, this is the tangent, at this point this is the tangent, at this point this is the tangent. So these are again perpendicular tangents. So likewise, there are the possibility of n number of infinite number of points. All these points if you join, then the circle so formed is called the auxiliary circle. Therefore we can conclude that the point of intersection, so the point of intersection, the point of intersection of the perpendicular tangents drawn to the ellipse lies on a circle. That circle is called the director circle. This is called what? This is called the director circle. At most 4 tangents can be drawn from a point to the ellipse. So this is the ellipse. So if this is the given point, if this is the given point, then so this is the normal. If this is a normal, this is the tangent. So from this point, this is the normal here. So if this is a normal, this is the tangent, and this is one normal. So if this is a normal, this is the tangent. and likewise this is the normal. So if this is the normal, this is the tangent. So therefore at most four normals can be drawn from a given point to the ellipse. The equation of the normal at the parametric point in theta, which is a cos theta comma b sin theta, is ax by cos theta minus by sin theta is equals to a square minus b square. Since this normal is passing through px1 y1. Where is px1 y1? Here this is px1 y1. So this is the normal. The equation of the normal at this point p theta, let us suppose that qx1 y1 otherwise. At this point p theta, this is the equation of this normal, and this normal is passing through qx1 y1. So this is ax1 by cos theta minus by y1 by sin theta is equals to a square minus b square. So this is ax1 by cos theta in terms of tan theta is 1 minus tan square theta by 2 by 1 plus tan square theta by 2 minus by1 by sin theta is 2 tan theta by 2 by 1 plus tan square theta by 2 is equals to a square minus b square. So from this, ax1 by 1 into 1 plus tan square theta by 2 by ax1 by 1 into 1 plus tan square theta by 1 minus tan square theta by 2 plus minus by1 by 1 into 1 plus tan square theta by 2 by 2 tan theta by 2 is equal to a square minus b square. So if this tan theta by 2, if you take it as t, then this is ax1 into 1 plus t square by 1 minus t square plus minus by1 into 1 plus t square by 2t is equals to a square minus b square. This, on simplifying, we will get by1 into t power 4 plus 2 into ax1 plus a square e square plus t into t cube plus 2 into ax1 minus a square e square into t minus by1 equals to 0. So where b square, wherever we get b square can be written as b square is equals to a square into 1 minus e square. So that also, if you substitute, then actually this is what we will be getting. So this is t power 4 t cube, t square is absent, t and constant equals to 0. This is a biquadratic equation. So t has got 4 values. Therefore, this equation in t satisfies at most 4 values. Therefore, totally 4 normals can be drawn from the given point. This is the first problem from third Roman. Show that the foot of the perpendicular drawn from the center on any tangent to the ellipse lies on the curve x square plus y square whole square equals to a square x square plus b square y square. So for example, this is the ellipse, and this is the center of the ellipse C. So show that foot of the perpendicular drawn from the center, from this center on any tangent. Let us suppose that this is the tangent. Let us suppose that this is our tangent. So this is the perpendicular to this tangent lies on the curve. So set of all such points lies on this curve is what we need to prove. So as usual, let the slope form of the tangent to the ellipse be y is equals to mx plus or minus square root of a square m square plus b square. So the slope of this tangent is m, because this y is equals to mx plus square root of a square m square plus b square itself is the tangent in its slope form m. Therefore, this line is having the slope m. So this point is the foot of the perpendicular. This point P x1 y1 is the foot of the perpendicular. The slope of a line perpendicular to this line in the sense, this is first equation of a line, is minus 1 by m, because the slope of this line is m and the line which is perpendicular to this line is this, and its slope is minus 1 by m, because this and this are perpendicular to each other. So therefore, equation of the line passing through the center C00 having slope minus 1 by m is, so y minus 0 equals to slope point form, y minus 0 equals to minus 1 by m into x minus 0. So this is y is equals to minus x by m. From this, m equals to minus x by y. Since this line is passing through x1 y1, which is the locus of the line, required line. This line is passing through P x1 y1. So this is equals to y1 equals to mx1 plus or minus square root of a square m square plus b square. Substituting m, we get y1 is equals to m equals to minus x by y. So this is minus x1 by y1 into x1 plus or minus square root of a square m square plus b square. Because this line is also passing through P x1 y1, therefore y1 equals to minus x1 by m. So m1 equals to minus x1 by y1 we have written here. So this is equals to y1 equals to minus x1 square by y1 plus or minus square root of a square m square plus m square. M is minus x1 by y1 plus b square. So this is equals to y1 equals to minus x1 square by y1 plus or minus square root of whole square n square. So a square x1 square plus b square y1 square. So the LCM is y1 square by y1 square. So y1 square being the LCM here. So this is minus x1 square by y1 plus or minus square root of a square x1 square plus b square y1 square by y1. Square root gets eliminated, so y1. This is y1 equals to. So y1 equals to LCM here is y1. This is minus x1 square plus or minus square root of a square x1 square plus b square y1 square. So cross multiplication we get y1 into y1 square. This minus x1 square if you take to this side, plus x1 square is equals to plus or minus square root of a square x1 square plus b square y1 square. So squaring on both sides, we get x1 square plus y1 square whole square is equals to a square x1 square. Square root and square will be eliminated. Plus or minus whole square is obviously plus. B square y1 square. This is our ellipse and this is the tangent and this is the center 0 0. So this point is Px1 y1. So what is this point? This point is the foot of the perpendicular drawn from the center of this ellipse to this tangent. So the locus of this point Px1 y1 we got it to be this. Therefore, the locus of Px1 y1 is x square plus y square whole square is equals to a square x square plus b square y square. The next question is, show that the locus of the feet of the perpendiculars drawn from foci to any tangent of the ellipse is the auxiliary circle. The auxiliary circle concepts they have studied before also. The circle described on the major axis of the ellipse as the diameter is called the auxiliary circle. That is, this is the ellipse and this is the diameter. So, the circle described on the major axis of the ellipse. The circle described on the major axis of this ellipse as a diameter. For this circle, the diameter is the major axis of the ellipse is the diameter of this circle. So likewise, this is the another definition of this auxiliary circle. It tells the locus of the feet of the perpendiculars. So this and this are foci, S dash. Feet of the perpendiculars drawn from foci. So from this and this, feet of the perpendiculars. So this is the foot of the perpendicular of this tangent and this is the foot of the perpendicular of this tangent. So this is the ellipse given and this is one of the foci and this is the tangent drawn and this is the perpendicular from this foci. One of the foci A is comma 0, S dash is minus AE comma 0. So this P x1 y1 is the foot of the perpendicular of one of the foci. Let the equation of the tangent in its slope form be y is equals to mx plus or minus square root of a square m square plus b square. Y is equals to mx plus or minus square root of a square m square plus b square. This is the slope form of the tangent. Since let phi x1 y1 be the foot of the perpendiculars drawn from either of the foci to the tangent. So since this p x1 y1 is passing through this tangent, from this y1 is equals to mx1 plus or minus square root of a square m square plus b square. Now this line is perpendicular to this tangent. This line is perpendicular to this tangent. So the slope of a line which is perpendicular, which is the slope of this line which is perpendicular to this tangent, the slope of a line which is perpendicular to this tangent is minus 1 by m. So this minus 1 by m is the slope of this line which is perpendicular to this tangent. So the equation of the line passing through the foci S plus or minus AE comma 0. So S AE comma 0, S dash minus AE comma 0. And having slope m minus 1 by m is true. So this is the ellipse given, and this is one of the foci, and this is the tangent drawn, and this is the perpendicular from this foci. One of the foci A comma 0, S dash is minus AE comma 0. So this P x1 y1 is the foot of the perpendicular of one of the foci. Let the equation of the tangent in its slope form be y is equals to mx plus or minus square root of a square m square plus b square. Y is equals to mx plus or minus square root of a square m square plus b square. This is the slope form of the tangent. Since let phi x1 y1 be the foot of the perpendicular drawn from either of the foci to the tangent. So since this px1y1 is passing through this tangent, from this y1 is equals to mx1 plus or minus square root of a square m square plus b square. Now this line is perpendicular to this tangent. This line is perpendicular to this tangent. So the slope of a line which is perpendicular, which is the slope of this line which is perpendicular to this tangent, the slope of a line which is perpendicular to this tangent is minus 1 by m. So this minus 1 by m is the slope of this line which is perpendicular to this tangent. So the equation of the line passing through the foci S plus or minus AE comma 0. So S AE comma 0, S dash minus AE comma 0. And having slope m minus 1 by m is y minus 0 is equals to minus 1 by m into x minus plus or minus AE. So this is equals to ny is equals to minus of x plus or minus AE. So this is ny plus minus x, if you take to this side, plus x is equals to plus or minus AE. So squaring on both sides. And before that, since this line is also passing through px1y1, since this line is also passing through px1y1, implies my1 plus x is equals to plus or minus AE. So this is squaring on both sides. We get my1 plus x whole square is equals to plus or minus AE whole square. So this is my1 plus x whole square is equals to a square e square. So the earlier one is y1 minus mx is equals to plus or minus root of a square m square plus b square. So if you square on both the sides, this is y1 minus mx 1 whole square is equals to a square m square plus b square. So this is 1. So all that we need to do is just an elimination of m from both this equation. So let us add these together. So let us add 1 and 2. Adding 1 and 2. So y1 minus mx1 whole square plus my1 plus x1 whole square is equals to a square n square plus b square plus a square e square. So this is y1 square plus m square x1 square minus 2m x1 y1 a minus b whole square. So this is m square y1 square plus x1 square plus 2m x1 y1 is equals to a square m square plus b square plus a square e square. So this is equals to m square y1 square minus plus 2mx1 y1 minus 2mx1 y1 gets cancelled. So this is y1 square plus m square y1 square plus this is m square x1 square plus x1 square is equals to a square m square plus b square can be written as a square into 1 minus e square plus a square e square. This is a square m square plus a square minus a square e square plus a square e square. A square e square, a square e square gets cancelled. So in both of them, take y1 square as a common, then we'll get 1 plus m square. In both of them, take x1 square as a common, then we'll get m square plus 1 is equals to, this is a square m square plus a square. Take a square as a common, m square plus 1. So 1 plus m square if you take common, this is x1 square plus y1 square is equals to m square plus 1 into a square. So these two gets cancelled on both the sides. Therefore, the locus of px1 y1 is x square plus y square is equals to a square, which is a auxiliary circle.